will be no day or night. The receding Earth will not remain behind them, but will be imperceptibly moving ahead. Where they left Earth, there is now only a point in space. If their objective is Mars, for example, they will not be moving directly toward it, but along a curving path, leading them to another point in space beyond the Sun. They must arrive at that point at the same time as Mars. Neither they nor the planet can stop and wait. On this trip, an error in injection velocity at Earth of less than 0.1%, that's about 25 miles per hour, will, if it goes uncorrected, cause the craft to miss Mars by over 1/3 of a million miles. The additional propellant and time required to correct so large an error near the end of the trip might be prohibitive. The mission would likely fail. But errors in spaceflight can be corrected during flight because the principles of space navigation are based on the knowledge that the forces involved are constant and predictable. In our solar system, each planet is locked into its orbit around the Sun by its particular velocity, the planet's momentum being balanced by the Sun's gravitational pull. The inner planets, where the pull is greatest, travel at greater speeds than the outer planets, where the pull is weaker. If a spacecraft is to leave the Earth for another planet, it must increase or decrease the speed imparted to it by the orbiting Earth. Yet, either way, this velocity change is a fraction of the orbital speed of the Earth, 66,000 miles an hour. The velocity imparted by the Earth also puts the spacecraft into the ecliptic plane. That's the plane of the Earth's orbit. It would take the expenditure of considerable energy to get out of that plane.